Hi everyone, welcome back to Cyber Talk with Nikolai show. And today we have Yuri Bulegin, and we're going to be talking a little bit more about hardware and all those chips that we are using and putting a lot of different applications on top of them. So some of the things that I think it's been neglected. Well, I don't want to say neglected, but people didn't pay enough attention who's manufacturing them, how they've been manufactured, and we came to trust that everything that we buy at the store when we put in our system, and then we load up applications and they magically work, but we don't know what we don't know. And I think Yuri has been on a quest to figure out what is working and what's not working, and shed some light on something that we don't know. So Yuri is a CEO of and co-founder of Eclipsium, a company that specializes in protecting hardware, as far as I understand. I was trying to find Yuri's bio online, and I couldn't find a whole lot of information. So welcome, Yuri, to the show, and thank you for participating and having this discussion. So I'm going to turn over to you. Just give some introduction to the audience so at least they know who you are and what you're up to, and give a little bit more information about your mission and what you're trying to achieve.
Hey everyone, Nikolai, thanks for hosting me here. Appreciate this opportunity to talk about that interesting topic. Certainly very interesting to me, but hopefully it's going to be interesting to folks who are going to listen to us. By the way of intro, or a little bit of a background, I've spent quite a while, over a decade of my prior life at Intel Corporation, looking for vulnerabilities and doing product security assurance, threat research in that space. And it was funny because I had very little knowledge before joining Intel on what can go wrong with the hardware, with the chips and everything that we use in our equipment infrastructure. But as I started work and started looking for exploring those complex systems, it became pretty obvious that it's the whole universe that is very complex, and a ton of things that can go wrong because of that complexity. And so that really piqued my interest a lot. So I spent over a decade looking for vulnerabilities, and not just in technologies and devices and chips that Intel has been building, but ultimately in the hardware of our systems. And at some point, it was fairly obvious that we have very little visibility into all this equipment that we're using, and it's so fundamental to everything we do, to all of the types of infrastructure that we're running and relying upon. So it was fairly obvious. So at that point, we've had that open source project that Alex and John and myself have been maintaining. It's called ChipSec. So that open source project was gaining popularity, and folks in the research community were using it. We've been using it extensively. Almost every research of security of different systems that we've been publishing was really using that framework, that project, and then I started noticing that organizations started using it to explore their servers and their PCs and other type of equipment for security problems and more. I mean, for security vulnerabilities, but also for any sort of compromise at that level. And so that was a trigger for me and Alex to team up and start Eclipsium, and start addressing that field for organizations that don't necessarily have the time and resources to actually spend on this. So quick intro.
Got it. Yeah, thank you for that. It's definitely interesting area, and like I said, it's a lot organization they didn't pay. I know Intel was trying in early days integrate security on the hardware chip, and I'm not sure how successful they were with it. But considering the latest story, I think people are going to start paying, organizations will start paying a lot more attention to it. Like from your perspective, like you've been doing this for quite some times, and again, I didn't know about your company until a couple of years ago when I met you at RSA, and we had conversation about all what is going on in this particular space. Like from your perspective, what do you think companies are missing? And because everyone is focusing on EDR, so everyone knows that yes, I need to buy EDR and I need to put it on my system, and life is going to become so much easier and so much happier for everyone. Not every case, but there are a lot of other things that traditionally even CISOs and cybersecurity professionals they're not really paying attention to because they're somewhat buried down deep and they don't have time to get and say, well, do I need to look at it or it's okay for me now?
Um, Thanks for your question, Nikolai. So couple of things. When we look at when we think of this hardware, those devices, whether it's a laptop or an IP camera or a VPN appliance, load balancer, or a server, um, we think it's a collection of chips, and then software stack, operating system, and apps on it. But the reality is, it's not. It's a collection of components that run a lot of software in them, that run their own operating systems. You take a network card; it's extremely complex subsystem that we have that runs its own OS, sometimes multiple OSs. If it's a more complicated kind of server grade NIC or smart NIC, then multiple OSs. You take a other type of chips, maybe a system on chip with multiple components in it. It runs millions of lines of code in multiple places on multiple microcontrollers that control different functions of that device. Take BIOS. A lot of that firmware was synonymous with BIOS in the past. There was somewhere in EEPROM, and um, um, firmware hub type of a chip that is not really updatable. It's been a long time ago. It's been over a decade, or even more. The system's moved on since then. Now we have extremely complicated this firmware subsystem, which is typically based on UEFI architecture for most of the systems today, and that's a very complex software architecture. Written in C, developed in the typical development environment with hundreds or thousands of different modules, different stages of execution, pre-UEFI initialization phase, and then driver execution phase, and so on and so forth. So it's an extremely complex software architecture. All of that is we observe everywhere across the board in multiple types of infrastructure and multiple types of equipment. It's all software based. So I like to use this phrase that software has eaten hardware because there's no longer hardware. It's all software for the most part, and as a result, it brings all of that, all the traditional software security risk, the vulnerabilities in that software, logical bugs, as well as standard coding problems that can be exploited by threat actors, via many different interfaces, including remote interfaces, completely remote interfaces. And it's all updatable. It's all designed to have very complex functionality, a lot of features. You can play a game even before you load the standard Windows in your so-called firmware environment, right? It's not simple anymore. It's very complicated with a lot of interfaces, with a lot of code, with a lot of vulnerabilities as a result. So that's the kind of the complexity we're dealing with, and at the same time, all of this code inside all of these components is very fundamental because the whole purpose of these components is to control the hardware and the infrastructure that we use. So control all of the functions of that equipment and infrastructure. A good example would be this so-called BMC chip, baseboard management controller, which every server in the world has. Some servers have multiple of these chips. But the whole purpose of that single chip is to provide remote lights out management of those servers and data center environments, including power management, reset management, firmware management, update management, and all of the virtual remote KVM, the virtual USB, mounting OSs and reinstalling OS on those servers. All of that is done through this chip, and because because the whole purpose is remote management, all of the interfaces it has are remote interfaces. We've heard about some of the interfaces like IPMI in the future. Sorry, in the past. In the future, it's going to be Redfish. So all of these interfaces are remote, and then of course the web interface for administrators to configure that lights out management subsystem, or BMCs, and local interfaces, because this subsystem needs to communicate with other parts of a server, and local interfaces typically provide communication between this chip, BMC chip, with the operating system on a server, or between this BMC chip and network card, or between this BMC chip and other things, other components on a server. And so what that means is that this separate chip exposes a lot of remote interfaces designed to provide remote management, and all of those interfaces are implemented in software running inside that chip. Typically, it's a Linux-based stack, with a lot of Linux-based components and services that have standard vulnerabilities, and most of these vulnerabilities are remotely exploitable vulnerabilities that allow remote attackers to compromise that BMC chip over some sort of a JSON parsing, or some sort of a standard web bugs, or maybe some more specialized Redfish type of bugs, and to execute their malicious code on that chip. Now that chip is separate from the standard OS, the OS that is running on a server. So imagine the power and the capabilities that those attackers gain by exploiting that chip as a result on that one server, and as a result on all of the servers in the data center. So that complexity is there. That complexity is what's being exploited, and that complexity is what's not visible to a lot of the tools that we have today, and it's also fundamental to all of the technology stack that is built on it, because it's part of a quote-unquote hardware, right? It's all fundamental to all of the rest of the technological stack that we run. So this combination of a fundamental and highly privileged technology layer, remotely exploitable and extremely complex, is what's makes it a very significant target for attacks, and a significant risk. So that's what we're very interested in addressing as a company, and addressing. And I've been interested personally in my professional career as well.
Thank you everyone for joining us for part 1, Cyber Talk with Nikolai, and a guest speaker, Yuri Bulegin. Stay tuned for part 2.
Thanks for joining us. For more information about these topics or IS Squared, please go to www.issquaredinc.com.